Hey guys, in this video we'll be covering the motors of the Stackr. We'll first be going over how they work and how we can control them. Then we'll go over the motor controller and its pinout. And finally, we'll be covering a test program, which should hopefully allow you to control the motors in a way that you like. So let's first start with going over how the motor works. And really, it's quite simple. By sending power to the motor, we're able to get the motor to spin. The more voltage we send to the motor, the faster it will spin. Now we can show this with a quick little demonstration. Here, I have a motor connected to a power supply. And if I turn it on, the motor will spin. Currently, the power supply is sending 3 volts. Now, I can increase the amount of voltage the power supply sends. Now I increase it to 4 volts, and we can see that the motor is spinning faster. If I continue to increase it, the motor will spin even faster. And of course, if I decrease it, the motor will start to spin slower. Currently it's at 2 volts. Now what's interesting is that we can also control the direction the motor spins simply by switching the direction of the current. Now when I turn the power supply on, we can see that the motor spins in the opposite direction. Before it was going counterclockwise, now it's moving clockwise. So how do we easily vary the voltage that we send to the motors? Well, to do this, we use something called pulse width modulation. This involves sending a signal where the high of our signal sends our set voltage, 6 volts, and the low of our signal sends no voltage, 0 volts. Now, the actual pulse width modulation refers to changing the ratio of the time that we send 6 volts high and the time that we send 0 volts low. This ratio is called the duty cycle, and by varying the duty cycle, we're able to change the average output voltage. For example, let's say that we send 6 volts half the time and we send low the other half. This would result in a duty cycle of 50%, and the average output voltage here would be 3 volts. Now, if we were to send high 75% of the time and low 25%, then our average output voltage would be 4.5 volts. And if we were to send high 25% of the time and low 75%, then our average output voltage would be 1.5 volts. As you can see, with this, we're able to easily change the voltage by varying the duty cycle, and thus we're able to easily switch the speed of the motor. Now, why do we need the motor controller? Well, the pins on our microcontroller, the Arduino Nano ESP32, are only able to send out a limited current and voltage. This limited current and voltage is not enough for us to properly power our motors. So the motor controller acts as a sort of medium where we could send the required voltage and current. The motor controller also acts as a way for us to quickly switch the direction of current being sent to the motors. Now let's take a quick look of how our motor controller is connected to the rest of our robot. Specifically, let's take a look at the pins on the right side in this diagram. We can see that we have 2 PWM pins. These are the 2 pins where we're going to be sending our pulse width modulated signals, which will control the amount of voltage that we send to the motors, as we talked about earlier. The letters A and B in the names simply allow us to distinguish between the two motors. We also see that we have a set of input pins. These input pins take a digital signal, which means that they can only receive a high value or a low value. And depending on what values we send to these pins, that will allow us to change the direction of the motor. Once again, we have A and B purely to distinguish between the two motors. We also have a standby pin, but currently we're not using that function, so we can ignore it. In this diagram, we see that the pulse width modulation pin for motor A is connected to pin D3 on our Arduino, and its two input pins are connected to D4 and D5. Now for our other motor, the input pins are connected to D6 and D7, and our PWM pin is connected to D8. Now this is important as we should avoid using these pins for other tasks in the future, as they already are meant to deal with this. Okay, now let's take a look at the simple test program, which should include all the necessities to controlling and programming our motors. So, we see here, in this first line, we're just including a library which should help us control the motors. This library is designed to work with the motor controller that we've included in the Stackr. Next, we define what pins on our microcontroller we want to send signals to. And we see here that the pins we've chosen are the same pins that we saw earlier in our diagram, the ones that are connected to the motor controller. In this case, that's pins D3 through D9. We've also named them to what they're connected to on the motor controller, which we again saw in the diagram, and we do this for the sake of consistency. Next, we define these two constants here for direction A and for direction B, and we'll go over their function in a quick second when we initialize the motors. Speaking of which, we do that right here. So we see that we initialize motor 1 and motor 2, and these will just represent the two motors on our robot. When we initialize them to be part of this motor class here, and we also initialize them with some specific parameters. The first three parameters are simply what pins we want to send our necessary signals through to control each motor, which you can see are the pins that we've defined earlier. Next, we also include this constant for direction, which we talked about earlier. And what this does is it sets our default for direction for the motors. So it takes either value from 1 or -1. And depending on which value it is, our default for direction will either be clockwise or counterclockwise. And now our final parameter is just a standby pin. And as I said earlier, we're not using this function, but it's still necessary when we initialize the motors. Now we can skip setup, we don't have anything in there, and we can move on to the main loop. Let's take a look at these first two lines. Here we're using this drive function, which is a method that's part of the motor class. And essentially what this does is it sets a given motor to spin at a specific speed. What speed exactly? Well, that depends on the value we give in the parentheses. See, this method can take a value from -255 to 255. And based on that value, it will spin with a specific speed and is in a specific direction. If the value is 0, then the motor will remain at rest and won't spin. If the value increases from 0, then the motor will start spinning with a speed in our default for direction, which, if you remember, we set here earlier. And if we give it a negative value, then it'll start spinning in the direction opposite to our set 4 direction. So in this case, all we're just saying is we want our first two motors to spin with a speed that should be roughly half of our max speed, and we want them to spin in our default 4 direction, which in relation to the bot will in fact be forward. Then we use this delay function in this next line here, and this just pauses our program for a certain amount of time. What time? Well, again, that depends in what value we specify here. This value is simply the number of milliseconds we want to pause for. So this should pause the program for 1000 milliseconds, or 1 second. Then we have similar code here next. Again, we're setting the speed of both our motors, except now we're telling them to move in the opposite direction from before. This should result in our robot spinning backwards. And then again, we wait for another second. So this set of code here should simply keep on repeating, and what it should result in a robot doing is moving forward for 1 second, and then moving backward for another second, then moving forward and then backward, and it should keep on repeating that. Okay, so now let's see our program in action. Over here, I have a Stackr which already has the program we just made loaded onto the microcontroller. And if we turn it on, we see that the bot moves forwards and backwards repeatedly, just as we intended with the program. Now, that should conclude our lesson on everything related to the motors in the Stackr. Thank you for watching.